There's a few more things to say about type parameters. First of all, you can in fact cast to a type parameter, but it's usually pretty pointless because what of course happens is that the cast gets replaced with a cast to the erasure of the type parameter, and also you're going to end up with a warning telling you that it's not type safe. So basically don't do it because it's not worthwhile doing it. Next, there's something about type parameters is that you can use them in other type parameters, and they can in fact be used from the point of declaration onwards. Although of course some types of use within the class body are not allowed. Doing new on the type parameter or using it in a static context, and I've mentioned all this before, so you already know about that. Right, let's take a look. Here's a generic type with a type parameter, and there's the declaration of it there. And there's a use of the type parameter there, and there's another use of it there. Now, when you first take a look at this, t extends comparable t, you may be a bit confused about what it's on about because it looks like a very awkward looking type, but in fact it's really simple and easy to understand. This one, it's very easy, and it occurs quite a lot actually. So what have we got here? This generic interface comparable t is actually in Java .lang, so it's a part of the system, and it's got just this single method in it, compare to, and the idea is you pass in an object of type t, and if the current implementing object is less than the one you passed in, it returns a negative integer, and if it's greater, it returns a positive integer, and if it's equal, it returns 0. Now, there's a recommendation that there's various forms of equality in Java. There's a dot equals form is available as well, and the idea is that you should keep it this and the dot equals should agree with each other basically. They don't have to, and if they don't, you should put a warning in to that effect. Now, okay, what sort of thing implements comparable t? Well, for a start, something like big decimal implements comparable big decimal, and date implements comparable date, and string implements comparable string, and timestamp implements comparable timestamp. And in fact, I think there may be an exception somewhere or other, but basically for any class x, if it implements comparable, it's going to be implementing comparable x. As I say, there may be an exception because some old non-generic legacy stuff, before there was any of this generic stuff, would implement comparable, in which case it may be comparable object, and I think there may be one or two cases where that happens, but if it does happen, it's almost certainly going to be the case that it will test it, and if it's not the type it expects, it will give an exception of some form or other. So basically, all comparables are going to look like this. So that's not really surprising. What it's saying is it implements comparable, so there's nothing really difficult about it. Now, what are the uses of comparable? Well, it gets used a lot in collections. When you want to sort things, it's very, very useful. And so things like the sorted set and sorted maps and stuff like that, all this sort of sorting is done using comparable. And this ordering, which is available in comparable, enables you to compare any two elements, any two things of a particular type, is called the natural order, and that's the one that gets used. Right, something that you can't do is something like this. Here you can see a use of a type parameter u being used here before it's been declared, and that will give a compiler error, fairly obviously, because basically this rule here prevents this sort of thing, and because this is basically a circular definition, you've got t there depending on u, and u depending on t, so it's a circular definition, and the rule that you've got to declare it before it's used prevents this circularity, so that's why it's there.